Hey, welcome back to another video of Wise Interactive Learning. In this video, we are going to go through the exercise 1.1 and particularly the first question out of it, which has 15 questions exactly on page number 12 of this book. But before starting on to that, I would like you to go through the concept video which is in the right hand corner of the I button. Also, watch this slide and pause the video to completely understand what are the formulas. And I am thinking as if you know all the prerequisites for this topic. So we'll go through all the examples in the batch of 5. So I've written down all the 5 first questions of the question 1. Then in the second part we'll see the next 5 questions, and in the third part we'll see the next 5 questions in a complete video. But there are 2 ways to do about this. One is traditional method, which is like if you take the function to check the continuity, it says that the f of x is limit x tends to 0 e raised to 5x minus e raised to 3x upon sine 2x. And if you want to solve this, how would you solve? Well, by the slide which I have shown you, you can adjust this function to as, I'll just not write this every time in every step. So I'll write as e raised to 5x. So I'll subtract 1, and to compensate it, I can add 1. So if I add 1, I can take negative sign common from e raised to 3x and then minus of 1. So what we have done is, we have compensated this minus 1. If we open the brackets, it will become plus 1. So we have done no change exactly. So in order to do this, we can divide this whole fraction by 5x and then we can multiply it by 5x. Also in this case, we can do it by 3x upon, we have sine 2x. So in this case, from this slide, you know that sine of any theta divided by theta when theta is approaching to 0 is necessarily 1. So we can divide this whole thing as 2 raised to x and then multiply it by 2 raised to x. So now watch carefully what is happening over here. So e raised to 5x minus 1 upon 5x, this whole term will become 1. Why? Because it's in the formula. You can check the slide. Also, e raised to 3x minus 1 upon e raised to 3x, this whole thing will become 1. So now what we have is 5x minus 3x, which is 2x, upon, what is this? Sin x, sin 2x upon 2x. When you apply limit, which is every time, so this will also become 1. So what we have is 2x. So your final answer is 1. Well, it was given that at x equals to 0, the value is 1. So what we can say is left hand side is equals to right hand side, and hence this whole function is continuous. So this is a traditional method. But what if you want to speed up all the equations very fast? I'll show you a trick. So let's see what is this trick. This trick is also called as L'Hopital's rule. But in order to do that, we have to apply our mental math to it. So in order to apply mental math to it, we'll see how we can do calculations faster. So what L'Hopital's rule says is, when limit x tends to 0 of any function f of x upon g of x is given, if this function is of form 0 upon 0 or infinity over infinity or any indeterminate form, it is always equals to limit x tends to 0 f dash of x, which is derivative, upon g dash of x, which is also the derivative of g. Well, you at this point might know this situation, but there is also a special condition for it, which says that this particular function should exist in nature. Now, we'll see how to do calculations and all these questions by L'Hopital's rule. So, first we'll take the first question and again solve it by L'Hopital's rule, and you can see that very fastly you can do all these questions. So, e raised to 5x minus e raised to 3x upon sine 2x. So, we'll rewrite it. Now, By using L'Hopital's rule, you know that you have to take a derivative. So e raised to 5x derivative is e raised to 5x into derivative of 5x, which is 5, minus e raised to 3x as it is, times the derivative of 3x, which is 3, divided by the derivative of sine of any theta is cos theta. So sine of 2x will be cos of 2x times the derivative of 2x will be 2. So this is given. So now we know that we have to check the continuity at x equals to 0. So when you plug in the values of x equals to 0 in all these values, what you have is these values will become 1. So watch carefully. E raised to 0 will be 1, e raised to 3x will be 1, and cos of 2x. So cos of 0 is always 1. So what you have is 5 minus 3 upon 2, which is 2 upon 2, which is 1. So you have your answer. Now let's take the second example, which is log of 100 plus log of 0.01 plus x whole upon 3x, and we have to check the continuity at x equals to 0. Now we'll simplify this. We can say that as log of a plus log of b is also known as log of a times b. So we'll multiply this, which is log of 100 times 0.01 will be 1 plus 100 times x is 100 of x. Everything divided by 3 of x. Now you know a rule from this slide, which is log of 1 plus x or any function, which is this rule, which is log of 1 plus f of x upon f of x. When x tends to 0, this function is equals to 1, right? So what we can do is we can divide this function, which is log of 1 plus 100x. We can divide this function by 100x and multiply by 100x. And what we have in numerator, we have is 3x. So you can see that these values will become 1 and x will get cancelled, and your answer is 100 upon 3, which is given over here. So we have to check. It means that if this is satisfying, it means that the function is continuous. Now let's check the third example, which is x raised to n minus 1 upon x minus 1 when x is going towards 1. We have to check it if it is equal to n square. Okay, so this is going limit x is going towards 1. So we'll check the indeterminate form. If we plug in 1, we have 1 minus 1, which is 0, then upon 1 minus 1, which is also 0. So it is an indeterminate form. So we can apply the L'Hopital's rule, which says that you can take the derivative. So derivative of x raised to n will be n x raised to n minus 1. So you know the basics. Minus 1's derivative will be 0, whole divided by x derivative will be 1, and everything is 0. So now when you plug in x is equals to 1 over here, what will be happen is n times 1 raised to n minus 1. But you know that anything raised to 1 will always be become to 1. So the final answer is n, right? So the final answer is n. But what are we given? We are given that it is at x equals to 1, the function is n square. So for understanding purpose, I have not written all the steps as if x is not equal to 0, x is equals to 0. Just consider this as x is not equals to 1 at this and x is equals to 1 at this. So which is the second step. So n square is not equal to n. So this function can be called as discontinuous. So if you watched this video till now, before going on to the fourth question, I would like to tell you that I'm not going into all the details of how the questions are solved like board exams. So I would like to tell you that the first link in the bio or the description is about a Telegram group which you can join if you want to learn exactly how to solve the board pattern solutions. So all these examples are very basic, which are required for the board exams, but they are not required on the JEE mains level. These are the foundations of the JEE mains or JEE advanced. So I would like to tell you that in order to get to that level, or just to write the board exams exactly the way you want to learn, you can join the Telegram group. And now we'll watch the fourth question. So the fourth question says is f of x is equals to log of x minus 7, log of x minus log of 7, everything divided by x minus 7. So see, you can do this by two ways. The traditional way, you also can do this. Also by doing L'Hopital's rule, you can do this. Why? Because if we plug in 7, which is, we have to check the continuity at 7. If we plug in 7 over here, it will become log of 7 minus log of 7, which is 0 upon 0. So it is becoming an indeterminate form, which is limit is x tends to 7. It is become indeterminate form. So now, before doing that, we can just do it by L'Hopital's rule. So what is L'Hopital's rule? You just have to take the derivative of numerator. So log of x, when we take derivative, it is becoming 1 upon x, and minus 7 is basically constant. So the derivative is 0. Whole divided by the derivative of x is 1, so minus 0. So which basically becomes 1 upon x. So limit is x tends to 7. So your answer becomes 1 upon 7. Right? And what is the answer given over here? So answer is given as 7. But the answer which we have got is 1 upon 7. So what will be the continuity? Well, limit x tends to 7, f of x is not equals to f of 7, right? Because at f of 7, we have the value as 7, which is basically 1 upon 7 is not equal to 7. So hence, this reason we can say that this function is discontinuous. Okay, so now moving on to the fifth question, what we'll see is, we'll do one question by the way of traditional method which is used in board exams, and we'll try to do one example by detailed solution, which is this question, which is f of x at x tends to 0, 1 plus 2x raised to 1 upon x. So we'll write step by step each and every step. So limit x tends to 0 of f of x. Okay, so it will be limit x tends to 0, 1 plus 2x upon 1 upon x. Now we need to understand one basic simple formula which is also given as, so we see that this is 1 plus 2x. So f of x is necessarily 2x. So we'll try to divide this and multiply this by 2. So it will become limit x tends to 0, 1 plus 2x whole power. We have to take 1 upon, we already have 1 upon x. So we can just divide it by 2 and then we can multiply it by 2. So what we have done is, we have taken the function 1 plus 2x upon 1 upon 2x in the bracket so that we can understand what is going towards e. So this whole value will become e, which is limit x tends to 0. So now we know that this value is e. So this will become e square because we have a square over here. So this is a constant function. So we don't have anything. So the final value will be e raised to 2. Well, this is limit x tends to 0 f of x, but we are given that at f of 0 we have the value as e square. So since these two are equal, we have LHS equals to RHS, and hence this particular function is continuous.